All right, here comes part 3 of our review on solving systems. All right, that includes systems of equations and inequalities. So let's go ahead and do problem number 1. We can solve this by any method. Even though they say any method, really one method is going to stand out for this one, and that is elimination. I notice that all variables have a coefficient, other than 1. So substitution would probably give us ugly fractions, so let's not go there. Let's eliminate, for example, the x's. If I were to take this equation and multiply it by positive 2, watch what happens. The top equation is going to become 4x plus 10y is equal to 30. The bottom equation remains the same, negative 4x plus 7y is equal to negative 13. So I can put these together. Those are going to cancel out, so I'm going to get 17y is equal to, oh, look at that, 17. How lovely. Then I'm going to divide by 17. And I am going to get y equals 1. So that's one of the values that I need. All right, but I'll keep going because I need x as well. So I can get x by taking this y and plugging it into one of these equations. I'm just going to use the top equation. I'm liking it, so that's going to be 2x plus 5y is equal to 15. So if I take this y equals 1 and I put it in there, so this is going to become 2x plus 5 times 1 equals 15. So that's 2x plus 5 equals 15. Subtract. So that's going to give me 2x is equal to 10. Time to divide. So that's going to give me x equals 5, which as an ordered pair would be 5, 1. So that would be the answer to problem number 1. Let's take a look at problem number 2. This one I'm going to do by substitution. The first step of substitution is to get one variable alone, and x is already alone. That's why it would be genius to use substitution. So this is going to go in there. So this is going to become 2 times parentheses plus 3y equals 43. I just put a parentheses instead of an x. And of course, in the parentheses goes y plus 4. If I do that distributive property, I'm going to get 2y plus 8, all right, plus 3y is equal to 43. Now I've got some like terms to do, all right, the 2y and the 3y. So if I put those together, I'm going to get 5y plus 8 is equal to 43. Subtracting that 8 is going to give me 5y is equal to 35. Time to divide. Okay, dividing by 5 gives me y is equal to 7. Now that's my first answer. All right, but I still need x. So it would be really easy to use this equation up here because we know that x equals y plus 4. Okay, I just copied that. But now we know that y is 7. So if I take this and I put it in for y, that's going to give me 7 plus 4. So therefore x equals 11. And as an ordered pair, we'd have 11, 7. Okay, so there's our answer number 2. All right, let's take a look at number 3. Oh, wait, whoa, hold up. Scary time. Number 3 is one of these triple systems. So let me walk you through a nice little tutorial of how you solve a triple system. What you do is 3 equations are entirely too much. So what we're going to do is we're going to pick just 2 equations at a time. Okay, so I'm trying to kind of decide which way I want to go. But for example, I could pick the top 2 equations as a pair, and I could do, say, the bottom 2 equations as a pair. Alright, it doesn't have to be the top 2 and the bottom 2. It could be the top 2 and then, like, say, these 2. Alright, it's up to you. But the idea is to eliminate. So I'm looking at this x. So if I did the top 2, I know I could turn this into a negative 2x and cancel that out. If I do the bottom 2, I could turn this into a negative 3 and cancel that out, because it's got to be the same variable both times. So you have to decide which variable you're going to eliminate, and you got to stick with it. So I'm choosing to eliminate the x's. So here's what I would do if I were you. I would recopy. So I just said my first pair is going to be the top 2. So go ahead and recopy those 2. So that's going to be 2x plus 3y plus 2z is equal to 1. And x plus 4y minus z is equal to 7. Like I said, I need to eliminate the x's. Alright, that's what I chose. So I'm going to multiply by negative 2 to make them opposites here. The top equation stays the same. So I'm going to have 2x plus 3y plus 2z is equal to 1. But the bottom equation is going to become negative 2x minus 8y plus 2z, right, is equal to negative 14. So if I combine these like terms, that's going to give me negative 5y plus 4z is equal to negative 13. Alright, I'm going to put a box around that and save it for later. It's my first box equation. Alright, I need to do that same thing basically again. So I did the top 2 equations, now I'm going to do the bottom 2 equations. So here I recopy. So I've got my x plus 4y minus z is equal to 7, and I've got 3x plus y plus 3z is equal to negative 2. Okay, I got rid of my x's last time, so I need to make sure I get rid of my x's again. So in order to make that happen, I'm going to multiply the top equation by negative 3. So this is going to become negative 3x minus 12y plus 3z is equal to negative 21. The bottom equation just stays the same. 3x plus y plus 3z is equal to negative 2. So if I combine these like terms, the x's cancel out again, and this is going to leave me with negative 11y plus 6z is equal to negative 23. So this is my second box equation. Alright, now all that's left is to take these 2 equations and treat them as a new system. So we'll put these 2 equations together into a system and solve it either by elimination or substitution. Now looking at these equations, I'm thinking elimination once again, because look at all these coefficients. Alright, I just copied the blue box. Just copy the red box. Alright, I'm just putting them together. So we're going to solve this system like we always would. Now I'm going to try to eliminate the z's. Now I could turn one of these into a 24 and a negative 24 by multiplying by 6 and negative 4. But if I'm clever, which I am, I will realize that these could more easily be turned into 12s. So if I multiply the top equation by 3, I'll get a 12z. If I multiply the bottom equation by negative 2, I'll get a negative 12z. And then my z's would be opposites that cancel. And the numbers will be smaller this way. So that's going to give me negative 15y plus 12z is equal to negative 39. Now the bottom equation is going to become positive 22y minus 12z is equal to positive 46. Alright, if I put these together, the z's cancel as predicted, but this is going to leave me with 7y is equal to 7. So when I go ahead and try to get y by itself, I'm going to divide by 7, and that's going to create y equals 1. So there is my first value. Now I'm going to stay with this system right here until I get the, I've got the y, but I also need the z. So I'm just going to stay with the same system and get that z. I can use either one of these two equations. I think I'll just use the top equation to get it. So so this top equation here is I've got a negative 5y plus 4z is equal to negative 13. If I take this y and I plug it in right here, that's going to give me negative 5 times 1 plus 4z is equal to negative 13. Okay, so obviously that's just negative 5 plus 4z is equal to negative 13. So if I add 5 to both sides, that's going to give me 4z is equal to negative 8. And then it's time to divide. So I divide both sides by 4. And I come out with z equals negative 2. Alright, so that's my second value. Alright, so now I have 2 out of the 3 variables I need. I have y and I have z. I still need x. So what you do is you take both of these values and you plug it back into one of the original 3 equations. Okay, either one of these that you want. I think I'll just use the top equation. Okay, so if I take this top equation and substitute, okay, I'm trying to find x. So I've got 2x plus 3y plus 2z is equal to 1. So y was 1 and z was negative 2. Okay, so this is going to give me 2x plus 3 minus 4 is equal to 1. So that's 2x minus 1, alright, I'm combining, is equal to 1. If you add 1 to both sides, that gives me 2x equals 2. If I divide both sides by 2, find out that x equals 1. Alright, so that is the third and final result that we needed. So that means overall, as an ordered triple, the answer is 1, comma 1, comma negative 2. All right, so this would be the final answer for number 3. So let's go ahead and take a look at number 4. All right, number 4 looks like another elimination problem. Might as well go ahead and eliminate the x's, because it would be pretty easy. All I'd have to do is multiply by 2. Now if I do that, the top equation becomes 6x plus 4y is equal to 10. The bottom equation stays the same, so negative 6x minus 4y is equal to negative 10. Very strange. Not only do the x's cancel out, but the y's cancel out. Even the 10's cancel out. Everything cancels out. Now, when all the variables cancel out, that's going to be 0. Well, even when the 10 cancel out, that'll be 0. So, what am I going to put for my final answer? Is this my answer? 0 equals 0? No, that's not an answer. Okay, but the way I know what the answer is depends on whether or not this is a true statement or a false statement. 0 does equal 0. So because this is a true statement, I know that the answer is going to be infinitely many solutions. Okay, which I feel like typing for some reason. All right, infinitely many solutions. So that's the answer. Just be aware, okay? I mean, that problem is done. That is the answer. So I'm just going to come over here to point out to you another possibility. Let's say, just for an example, that it had been more like this. Say if we had had the same thing, like 6x plus 4y, okay, but instead of 10, so let's say it was 15. And let's say the bottom equation was the same. Negative 6x minus 4y is equal to negative 10. So when I went to put these together, still the x's and y's would have all canceled out. So I would have had 0. But over here, I would have had 5. All right? So how do I interpret this? What do I put as the answer? Well, because this is a false statement, 0 does not equal 5. That is a signal to me that would tell me that there must be no solution. Okay, this is not what happened in this particular problem. This is just a hypothetical situation. Okay? So just understand, if it comes out as, if all the variables cancel out and you get something equal to itself, put infinitely many solutions. If all the variables cancel out and you get something that's not equal to itself, that's when you put no solution. Okay? But this is the actual answer. Anyway, I just want to emphasize that because we had a quiz recently and most of us got that wrong. Poor kids. Okay, a word problem. Oh goody, oh goody. We need practice on our word problems. Alright, I guess I'm gonna have to break down and zoom out. I don't like zooming out. I like things to be big. Okay, here we go. Gotta rock this word problem. A group of students go out for lunch. If 2 have hamburgers and 5 have hot dogs, the bill will be $8. If 5 have hamburgers and 2 have hot dogs, the bill will be $9.50. What is the price of a hamburger? Well, this is one of those problems where maybe you noticed that the two sentences sounded almost the same. Let's go ahead and define our variables. what is the price of a hamburger? So the variables will be prices. Let's go ahead and do hamburger and hot dog. So I'm going to let, well, you know what? I'm just going to go ahead and use H and D for hamburger and dog, hot dog. Okay, so I'm going to let H equal, and it says what is the price? So be specific. H equals the price of a hot dog. And I'm going to let, no, wait, I lied. I'm letting H equal the price of a hamburger. Why does it keep jumping around, man? Price of a hamburger. And I'm going to let D equal the price of a hot dog. Okay, I'm using H and D. Now, I need some equations. I need two equations. The two equations in this particular problem, they just come straight from the sentences. All right? Okay, if 2 have hamburgers and 5 have hot dogs, the bill is $8. All right, that's an equation right there. All right, 2 hamburgers. So $2 per hamburger plus $5. I mean, not $5. 2 hamburgers. So 2 times the price of a hamburger, 5 times the price of a hot dog, should give me the total amount of $8. So there's my first equation. Now the second equation, we'll slightly change colors on this one. This time 5 have hamburgers and 2 have hot dogs, and the bill is $9.50. So that's 5 have hamburgers and 2 have hot dogs, and the bill is $9.50. So these are the two equations I'm dealing with. And that's it. It's time to solve this out, and we could just use elimination. All right. So let's do that. If I do some elimination, it would be good to, let's see. They want us to find the price of a hamburger. So I'm going to eliminate the dogs. That will just leave hamburgers. So let's eliminate the dogs. Save us a step. So I can eliminate the dogs if I multiply the top by 2. All right, that'll make 10. If I multiply the bottom by 5, -5, because that'll make -10. So that's going to give us, so the top equation becomes, let me zoom in a little bit. Alright, so the bottom equation becomes 4h plus 10d is equal to 16. The bottom equation becomes 25h plus, wait, that's a -5, isn't it? Uh-oh. Let me see if I can modify some stuff. Okay, so that's -25, okay, minus 10d is equal to, 5 times 9.5, okay, or -5 times 9.5. Okay, so that's -47.5. Okay, so when I combine these like terms, the d's go away, and I'm going to have -21 H is equal to, let's see if I combine these. Okay, there's my negative 47.5. I just need the plus 16. So that's negative 31.5. All right, so if I go ahead and divide both sides by negative 21, what do I get? Let's see. I could just take this and go divided by negative 21. So I get 1.5. All right, in the back of your mind, be thinking $1.50. Okay, so that's H is equal to 1.5. So that is our first value. Oh, actually, you know, because this time they just said, what is the price of a hamburger? We're actually done. All right, we need to write a sentence, but normally we would have to take this and plug it back in, because usually I ask you for both values. But if I do only ask you for one, and you happen to find it first, then, you know, you can stop. Okay, so, text box. Alright, you know what, even though I only asked you for one, I'm just like, my OCD is kicking in, and I'm like, I gotta find the other one. So I'm gonna do that. So, switching to red. You can use either one of these equations. I'm gonna use the top equation, 2h plus 5d is equal to 8. I like it because it doesn't have any decimals. So if I take this and put it in for h, so that'll give me 2 times 1.5 plus 5d is equal to 8. So that's going to be 3 plus 5d is equal to 8. Subtract. So that's going to give me 5d is equal to 5. Divide. And that is going to give me d is equal to 1. All right, so a hamburger is $1.50 and a hot dog is $1. So let's just go ahead and put that in a sentence form. It's a text box. I thought this was a text box. Maybe it was not a text box. All right. There's a text box. A hamburger costs $1.50. All right, that was the actual answer to the question. The rest of this is extra information. Also, you know, I'm just going to say, by the way, a hot dog costs $1. Not that anybody asked. It's just good to know. Okay, boom. Now that's an answer, if I ever saw one. Alright, so there's a nice word problem for you. It's good practice. Love it. Speaking of word problems, okay, the last problem on this particular review is a linear programming problem. So let's remember how we do it. I'm just going to read through it real quick. Andre makes 2 types of wood clocks to sell at local stores. It takes him 2 hours to assemble a pine clock, which requires 1 ounce of varnish. It takes 2 hours to assemble an oak clock, which takes 3 ounces of varnish. Andre has 15 ounces of varnish in stock, and he can work 18 hours. If he makes $4 profit on each pine clock and $5 on each oak clock, how many of each type of clock should he make to maximize his profit? Okay, first we have to define our variables. I look to the end. I look to what are we being asked to find, and that's how I define my variables. How many of each type of clock? So the variables need to represent each type of clock. Well, how many? So the 2 types of clocks are pine and oak. So I'm going to let X be the number of pine clocks, and I'm going to let Y be the number of oak clocks. Pine and oak. So let's go. Constraints. Remember, a constraint is just a limitation. So I scan the problem looking for any mention of a limitation. So blah blah blah, takes this, takes that. Andre has 15 ounces of varnish in stock. That's a limitation. Okay, 15 ounces of varnish in stock. That's all he's got. So we have ourselves a varnish limitation. So let's write that down. Varnish. Okay. So since I have a varnish limitation, I should hunt through the entire problem looking for any mention of varnish. And it's going to say something about a pine clock takes this much varnish and an oak clock takes that much varnish. And that's how I will build the rest of this constraint. So it takes him 2 hours, okay, fine, which requires 1 ounce of varnish. There it is. We're working on the varnish constraint. So let's highlight everything pertaining to varnish. Alright, so that's for the pine clock. What about oak? 2 hours, yada yada. But here we go, 3 ounces of varnish. So these 3 things I've highlighted in yellow. Varnish, varnish, varnish. That's how you build the varnish constraint. So 1 ounce of varnish for every pine clock, which is X, plus 3 ounces of varnish for every oak clock, which is Y, has got to be less than or equal to the total amount of varnish, which is 15 ounces. So there's my varnish constraint. 1 per pine clock plus 3 per oak clock has to be less than or equal to 15 total. So let's change colors and look for another constraint, another limitation. Let's see. Andre has 15 ounces of varnish, and he can work 18 hours. Okay, that is a constraint. That's a limitation. He can only work 18 hours. Okay, so this is a time constraint. So let's label that time. Okay, he has a time constraint. 18 is the max. That's going to wind up over here on the right hand side. But before I do that, let's hunt through and see, okay, how much time for a pine clock, how much time for an oak clock, time constraint. It takes him 2 hours to assemble a pine clock and 2 hours to assemble an oak clock. So 2 hours, total of 18. That's 2x plus 2y is less than or equal to 18. Okay, that bell you just heard is the bell for my lunchtime. So I'm going to pause this video. You'll never miss me. Alright, so fine, those were the 2 main constraints, but before we get off of constraints, there's one more thing we have to talk about, and that is the reality constraints. Alright, we're talking about objects, clocks. You cannot have negative clocks. So that means that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. Please make sure you include the reality constraints among your constraints. And as far as the graph goes, that just guarantees that we are in the first quadrant. X equals 0 is the vertical line, and being greater than it means that we have to stay on this side of the line, which is lucky because I didn't include the other part of the graph paper. Okay, and then y equals 0 is a horizontal line. Because it's greater than, we're going to stay on this side of the line. So that's your reality constraints. Now we need to graph the other constraints though. Let's start with the varnish constraint, which is x plus 3y is less than or equal to 15. So subtract 3y from both sides, and that's going to give us, why am I subtracting 3y? Oops, I didn't mean that. Okay, erase that. I meant subtract x from both sides. So that gives us 3y is less than or equal to negative x plus 15. Let us now divide by 3 to get y by itself. Okay, don't forget there's sort of an invisible 1 right there. So we're going to now have y is less than or equal to negative 1/3 x plus 5. So this is our first constraint other than the reality ones. And let's graph it. These numbers look small enough that they should fit without changing the scale. So 1, 2, 3, 4, 5. So we'll put our first dot here. And down 1 over 3. Like so. Down 1 over 3, down 1 over 3, down 1 over 3. Let's go ahead and draw this thing. All right, and because it's less than or equal to, we should stay below this blue line. So don't scribble big, just put a little grass on it. So that means so far we're in this triangle, but we still have one more constraint to go. So let's now do the time constraint, which I've got here in red. So that's going to be 2x plus 2y is less than or equal to 18. You would subtract 2x from both sides. So that's going to give us 2y is less than or equal to negative 2x plus 18. And then we need to divide by 2 everywhere. So divide by 2, divide by 2, divide by 2. Okay, so that's going to leave me with y is less than or equal to negative x plus 9. Alright, the 2's cancel out. That's a 9, not a G, by the way. I don't like it. It's going to bug me. Okay, so let's go up to 9. So that's 5, 6, 7, 8, 9. Alright, so we've got 9 happening here. And this is like down 1 over 1. So that's going to be like this. Okay, so as I draw that line, you can see what's happening here. And because this again is less than, let's just put a little bit of shading on the below side of the line. Okay, so you can probably see that this is going to be our feasible region right here. All right, so there's our feasible region. There are 4 vertices. Here, 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 and here. So that is 0, 0, 0, 5. Whoops, I already did that one. Okay, this one is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. This, of course, is 1, 2, 3. Okay, so this is the point 6, 3. And this one is 9, 0. So these are our 4 vertices. And they will need to go into the objective function, which we have not yet created. So it's time to create the objective function. The objective is what we are shooting for. What we are trying to accomplish is called our objective. Our objective is clear, profit. Okay, what's the maximum profit? And how do we get to it? So let's highlight everything that has to do with profit. Okay, he makes $4 profit on each pine clock and $5 profit on each oak clock. So those are the 2 numbers that will go into our profit equation. 4x plus 5y is equal to the profit. So let's just write that down. So we are talking about a profit equation, and we can just call it P equals 4x plus 5y. All right, profit. And we will substitute our vertices in one at a time. So if I do 0, 0, everybody knows what's going to happen with this. Surprise, surprise, you get 0. Now if I put in 0, 5, well, that gives me 25. Okay, and if I put in 6, 3 is next. That gives me 39. And then finally I put in 9, 0. And that's going to give me 36. Okay, so it's clear that the maximum profit is $39. And that comes from the point 6, 3. So let's just write that down off to the side real quick like. Okay, I'd like us to write this down. Max equals 39 at 6, 3. Min equals 0 at 0, 0. Alright, but that is not good enough. We have to translate it back into words. Alright, so make sure your summary statement is a sentence. So for maximum profit of $39, all right, there's your profit right there. He should make in the 6, 3 The 6 was pine clocks, and the y value, the 3, is oak clocks. So he should make 6 pine clocks and 3 oak clocks. Okay, make sure you make a nice summary statement at the end. And that is the end of not only this linear programming problem, but it's also the end of our entire review. All right, I hope this has been helpful, and I will see you on the next video.